the next part is about the left approximation. Okay, the left approximation, um, use the same graph here as a quarter of the graph of the cosine from 0 to pi with 4 equal subintervals. Okay, we made a list of the left endpoint, the left end at 0 at pi over 4, 2 pi over 4, which is pi half, and 3 pi over 4. So to make a rectangle, so use the left end, so the left as the height of the bar. You see this is an example of decreasing function. So use the left endpoint, gonna give you overestimation. So you gain every single rectangle. The extra area here, which is pretty much the error of approximation. So using the left approximation, the delta x is the same. The delta x is pi over 4. And the function, which is the cosine of x over 2. So the left approximation, the A as the area, using the left approximation is the sum of the function at the left ends. So going to be the left ends. So the function at 0 plus the function at pi over 4 plus the function at pi over 2 plus the function at 3 pi over 4, and then multiply by pi over 4. Okay, same setup. Yes, go ahead, put in the calculator and let me know what you get, or type in the chat or turn on the microphone to share with the class. This time you will see the number is higher than the 2.01 because we gain more than, well, the last time we used a midpoint, we did gain and did lose, during each computation. But this time we gain all the time for all 4 bars. So that means we have the extra area. So the value gonna be greater than the 2.01. All right, we got the number. Thank you, Jonas. So it's 2.36693 if we use the same pattern like 6 decimal places. So I'm gonna wrap up to be 3.1. Okay. Already. Question for part B. You guys still working on computation, on calculating? Do you have any problem getting the same number? So my calculator comes up. So let me set up a little bit before I share with you guys. Oops, it been. Okay, do you guys get the same number? All right. So let me see if I can manage this. So this is my TI and I'm sharing. this one. So I check the mode is already in the radian mode, so I'm good to go. So second quit, and I'm computing the value. Since I am going to find the sum, so I put the parentheses and cosine of 0 plus cosine, oops, wrong one. I cannot use this, so go back, clear, quit. There you go. So the cosine of 3, this is the left, so going to be pi over 8. The second pi divided by 8, and then parentheses, and then plus another cosine of pi over 4 plus the cosine of 3 pi over 8, 3 pi divided by 8, close it, and then close the parentheses. This is the sum, and then multiply. What did I do? What did I do? So I already got the answer. Let me see what I have. The entry, second entry, second entry. My entry is gone, so let me try again. Anyway, so parentheses, cosine at 0 plus cosine at pi over 4. No, pi over 8, sorry. Pi over 8. And then cosine of pi over plus close it, and then multiply by the quantity pi over 4 divided by 4. Close it, and then enter. The number comes out to be 2.3669306. That's what we got. And then if we recall the previous command, like if we found out something wrong, so you see the entry, if I can draw it in here. Nope, it didn't go. So the blue one, the entry above the red button, red enter button. So you, what did I do? Second, and then enter. So it comes up with whatever the previous command that you use. If you fix it to be like to use it for the next approximation, so you just use the same pattern, but you just change the number into the list of the number that we made it for the right endpoint approximation. So for the right endpoint approximation, we're going to use the point pi over 4, pi over 2, 3 pi over 4, and pi. Then we do not need the function at the point 0. So that point, it can be replaced with the last endpoint. So you can replace the 0 with the pi value. So in this case, I'm going to replace it with the pi. So I'm going to use my mouse. Oops, wrong one. Where did it go? So replace the point 0 here with the value pi, which is the last endpoint. And then enter and see the number comes out. It comes out to be, oops, did I miss anything? So let me see the cosine. Oh, it has to be pi divided by 2 because the function is the cosine of x over 2 and x is pi. So I made a mistake. So I'm going to recall the previous command using the second enter and it bring back the previous command that I made a mistake. Okay, I'm going to fix pi here to be pi over 2. So I'm going to insert. So second delete, that means I'm going to use the insert function and I'm going to add the divided by 2. So it's added divided by 2 into the command. And now I'm going to find out what is my result. So my result is 1.58153. That is the answer. So this is the kind of the use of the calculation when you have to deal with the long expression in calculation. You and it's kind of repeat almost the same pattern. You can recall the previous command and then just adjust the value a little bit, so you don't have to type the whole thing again. Okay, so the answer for the right endpoint is 1.58153252. So um, you can verify with your calculator um, if you have a chance. So I'm gonna set up real quick as a summary of the right endpoint approximation. So in part C, for the right approximation with the graphical way, since we have the graphs, partial of the cosine graph from 0 to pi, make it into 4 equal subintervals and use the right end. So the right end for each subinterval. The last one is kind of something because the height here is 0. Okay. So at the point 0, pi over 4, pi over 2, 3 pi over 4, and 0. Now the right end point, the area using the right end is the sum of the function at pi over 4, function at pi over 2, plus the function at 3 pi over 4, plus the function at pi multiplied by pi over 4, which is the width or the delta x. And this is the sum of the cosine pi over 8, cosine of pi over 4, plus cosine of 3 pi over 8, plus cosine of pi over 2, and then multiply by pi over 4. See the last one, the height is 0, which is from the cosine pi over 2 is 0. So the function value and the function value and the height of the graph, it should go together. Otherwise, something wrong as part of the process that you are working on. And the number that we got is 1.581532, as we keep 6 decimal places. For this case, the right approximation, you see the cosine graph for the interval 0 to pi. This portion, the graph is decreasing. If we use the right approximation, we are losing all the time. We are losing. So this case is going to be under approximation or underestimation. Okay, so 3 different ways to use the Riemann sum, and the name tells you how to set up the problem. And overestimate, underestimate depends on the type of the function, whether it's decreasing or increasing.